Hi, DDSolar here. I'm building solar panel frames out of reclaimed and scrap lumber. For this project, I'm using structural screws, which are also lag screws. They are intended for treated lumber and outdoor use. I've been using this type of screw for a long time. They are very good for structural work, and they are much more robust and less likely to shear off or bend, and I really don't believe they can be pulled out under normal circumstances. Also, they have a large head, which means that you don't have to worry as much about using a washer, and they are much better for holding power. If you're trying to hold a piece of wood onto another piece, the wider head is almost like having a washer built right in. This particular type of screw has 3 layers on it. It has a zinc layer, so much like galvanized hardware, it's just a layer of zinc that's been applied. It also has a anti-corrosion coating, and then it has an outer layer of ceramic, which is interesting because you can feel it on the screw. It's very smooth. This particular brand of screw claims to have been salt spray tested for over 1,000 hours without any failures. If that is true, then that should provide additional survivability against treated lumber. Treated lumber is known for destroying fasteners and metal because of the corrosive chemicals that are inside the wood. Normally, pre-drilling is not required. I do pre-drill a lot because it helps me line up the screw. If you pre-drill and you keep it straight and everything's square, when you put the screw in, usually the screw will follow the path that you've pre-drilled, and it's a lot easier to keep the screw straight. If you don't pre-drill, you've got to make absolutely sure the screw is put in straight, or it will end up coming out the side of the material, or it will just end up somewhere where you don't want it to be. The drive method on these screws is the Torx T30. It's similar to the deck screws I used to use, but larger. And I do find that as long as you seat the bit correctly in the screw and there isn't a manufacturing flaw on the screw, pretty much the bit will never slip. Some of the screws have a manufacturing defect where there is some coating material that has gotten into the head of the screw, and it prevents the bit from interfacing properly. Unfortunately, there's quite a few of those. I'm finding quite a few of them in each batch. I've put those aside, and I'll probably try to figure out some way to clean those up and use them for another application later. Here's what I have so far. They're going to be 156 by 45 inches. I'm using structural screws, and the wood is unpressure treated. These are the panels that will be attached to the frame. They're 210 watts monocrystaline, and they're really lightweight panels. I really enjoy working with them. In the past, I've used a lot of deck screws, which are not very strong, and now I'm using these structural screws, which you can see on the ground. I'm using 1.5 inch stainless steel washers. These are fender washers, and I'm also using 2 different sizes. This is a 3-inch, and I believe this is a 6-inch. Now these are the thinner ones. I believe they're number 12. Yeah, I don't have it in front of me, and there's number 14. So these are thinner. However, I'm putting 2 per corner, and they're really, really strong. These are ridiculous. This type of screw has tremendous holding power, and they're very, very strong. These are only 3 inches long, and they're good for where you're sandwiching 2x4 materials together, or 2x. These are good for when you're making something at a corner, and there's going to be a flexing action on it. You want to make sure it's very, very strong. Of course, you still need to brace the structure, but these are fantastic. I just love these screws. I can't stop using them, and I found a place to get them for a fairly good price. They're going to cost more than deck screws probably, but they're worth it. The wood that I'm using is reclaimed and recycled lumber, so it's warped and twisted. I'm very thankful to have these long 2x. I believe that is a 12-footer right there. I still have to scab on some additional material at the end, but I'm not too worried about that. Current progress is I've got some of the pieces cut. I've done 2 of the corners. As you can see, I'm using 2 of these 6-inch structural screws. One of them has a 1.5 inch stainless fender washer. Over there you can see the other corner that I've completed. Now these corners will receive additional bracing material and diagonals, but this is just to tack the frame together. Okay, I'm going to go ahead and do this corner on camera. Okay, there's the third corner. I got one more to go. And you can see there's an additional piece of material starting right here. This is an additional piece of material. And there's going to be another piece of 2x running right along here. Those clamps are on there right now because this 2x4x12, I believe it is warped and twisted. So unfortunately, I'll have to put some clamps on it overnight and try to straighten it out. This one over here is also kind of out of alignment, so I'm just going to leave them like that overnight, and hopefully it will help straighten this frame out. I want to make sure it's square and flat. Okay, next I need to cut a piece of filler material 9 inches long for the other corner. And I wanted to show this little green Ryobi 18-volt miter saw I've been using. This thing really surprised me. It's mostly metal construction. I'm quite happy with it. It uses an 18-volt battery. I've got my biggest battery in there. So just going to keep using it. I've got quite a few cuts on it. And so far, so good. There's the fourth corner all done, and I still have to put the filler material in, and also I have to leave these boards overnight with blocks on them. I'm hoping to straighten them out. Who knows how much good that's going to do, but I'm going to give it a try. I've had some success using this method. And here's the detail for the corner. The corner is going to have a 9-inch long filler piece, which is right here. And because of, I don't really like this arrangement here, I'm being very careful, and I'm using a lot of fasteners. I'm using 4 6-inch structural screws, which go all the way into the material about this far. And I'm going to take 2 3-inchers and come in from 2 different directions on the outside. That's going to be tricky because I have to miss these fasteners here. Once I've done that, I can just go ahead and tie in the long piece, which is right here. Using normal methods, I don't have to worry about it. But I got to make absolutely sure this corner is very, very strong because I don't want it to be a failure point. If there's a wind gust or something, I want to make sure there's plenty of fasteners and plenty of wood. There's the corner. Now it has the 9-inch piece spliced in. That's this piece right here. I really don't want this piece to be here, but my 2x4s are not long enough. I've also got 2 structural screws way down here. Remember, these go 6 inches, so they're way out here. I did manage to get a fastener in right there from the other side. It's a bit tricky because these guys here are coming in, and you got to make sure and miss those. Also, this is recycled wood and it has nails in it, so it's extremely tricky to get these fasteners in without hitting something. The next job will be to take this piece here, which is a 12-foot 2x4, and join that in to this piece here using this piece, which is a couple feet long. And this is going to tie everything together and hopefully make this a very strong corner. Hopefully it won't be the weak part of the frame. There's the join. This is the 12-footer. This is the piece behind it. That's the 9-inch filler. And it should be pretty good. Got another structural screw right there. And I've got another structural screw right there. So it's locked in pretty good. This 2x4x12 has a warp in it. So what I'm doing is I've got concrete blocks on either side. And in the middle I've got these nails holding it up off the ground about 1/4 of an inch or so. And then the concrete blocks are bending this 2x4x12 over these nails slightly. And I'm going to leave it that way a while and see if I can take some of the warp out of the board. I don't know if it'll work or not, but it's worth a try. I like to repurpose and reuse anything and everything that I can. A while back I bought a riding lawnmower which came in an elaborate steel crate which had a lot of pieces like this. It's a thick steel tube with a flat plate and a hole in the end. When I saw these, I made sure and kept them because I knew I was going to be using them for something. And sure enough, I'm using them on my solar panel frame. This is the second solar panel frame I've used these pieces on. I still have a few left, and I'm very happy because I will be using those as well. I used a 3-inch structural screw and a 1.5-inch fender washer, stainless steel. And this will really give good diagonal bracing to this frame. I spent a lot of time getting it into square, and I was very, very careful when I built it. And I don't want to accidentally knock it out of square and have to start over again. And there is the final diagonal brace installed. Next, I'm going to lay the frame down on top of the base platform, which is behind it, and start installing the hinges. I have the frame laying on top of the base platform. I can start work on aligning and installing the hinges. There's going to be 3 steel hinges which were recycled from the doors on the shed which was torn down. I have my solar powered lighting set up. I'll show that at another time. Right now I'm doing the hinges, and I decided to just put the frame at 90 degrees to the base. I want about 5 inches of overhang, and this will give me about 5 inches because those are 2x6s and they're 5.5 inches high. The hinge is probably an inch or 3/4 of an inch. So I'll just snug the frame up against the base, put the screws in, and it's a little bit warped, so I will have to fool around with it a little bit and get everything in alignment. There's going to be 3 hinges, and I'm going to use structural screws where I can. I have to be careful here because there are other fasteners in here and I don't want to interfere. So probably this one here will be a deck screw just for alignment purposes, and then there will be 2 structural screws for attachment. Here there will be 2 structural screws as well. The hinges are sitting directly on pressure treated wood at the moment, but before I do the final installation, I will place 2 layers of tar paper in between the treated lumber and the metal hinge. Now I'm going to clamp the hinge down to make sure it doesn't move while I'm installing the fasteners. There's the completed hinge with 5 structural screws. I was able to get away with using 3 3-inch structural screws, so that's tremendously strong. It should not ever come loose. The bottom 2 screws will have to be removed temporarily before I can transport this thing out the door and set it up. All 3 hinges have been installed. So now I need to put some grease on the hinges because they're really, really old and they are a little bit crunchy and grindy, and also I don't want them to rust anymore, and they have to internally. So I'm going to go ahead and use some of this DuPont Pro Grease Lithium. Stuff seems pretty good, and it should help these hinges last several years, I hope. Here's the final setup. The middle of the solar panel frame has a black steel bar. You can see there right in the middle, right there. And that determines the tilt angle. Currently I have them at an angle that is more or less wintertime. It's not an exact angle, it's not a calculated angle. And I'm only going to adjust them probably for winter and probably for spring or summer, and that'll be about it. I don't have the need to constantly be out there adjusting them every time the month changes over. And right now I have a structural screw and 2 stainless steel washers attaching the tilt adjust bar. This is not necessarily how I'm going to keep it, but it will get me up and running. On either side of the frame there's going to be a piece of 2x4 which is cut to fit, and it will support the outer sides of the frame. That will prevent the frame from warping, twisting, or waving around in the wind too much. And these props are not really to adjust the solar panel angle, they're just there to support and strengthen the panel. The black steel bar in the middle is where the actual tilt angle adjustment will take place. In the middle of the frame I've added two pieces of 2x4 material. See them right there and right there. Those are there to support and enhance the strength of the frame where I attach the steel bar. This is in case I drill multiple holes for different tilt angle adjustments, and it shouldn't compromise the structure too much due to that extra material. I use two 3-inch structural screws per block to attach it, not counting the structural screw that attaches the tilt angle adjustment bar. At this point the frame is pretty much complete. I'd only need to install the two props at either end, and that isn't very difficult. And frankly, I'll probably do that after the solar panel frame has already been put out in my yard. Okay, so I don't have the hardware I need. It's the next day, and I want to get this thing out of my workshop and get my panels on it and start producing electricity. The hardware is going to be something I will either make myself or find. I know what I need, but I don't have it. So I'm using scrap 2x4 blocks, and you can see them right on the end. There's one right over there. There's another one right there. And those are going to support the panels in the low or summer position. There's also a stowed position which is nearly flat, which I'm not showing. Now I'm going to raise it into the winter position, which is higher up, and I'm going to install some temporary 2x4 blocks for that position as well. I've decided this frame is worth better hardware, and so I'm going to use the 2x4 blocks to get me by, build my own hardware, and then install that later in the field. Alright, very close to bringing this thing outside. I added that metal bar right there and one on the other side. I decided to use my last two metal bars that I recycled because I want to make sure this frame is as strong as possible. What you see there is the winter position. I'm going to use that angle for winter and probably a good chunk of the year. I'm eager to get this thing out of my workshop and outside producing power. All I have to do is put some small blocks of wood on the sides of the frame right over here to help support the edges of the solar panels. I deliberately allow the solar panels to hang off 1.5 inches. That's to help keep weather off of the frame. I'm considering adding some additional tilt positions after I get my hardware. I want some really good hardware. After I do that, I may add one or two more additional tilts for different seasons. It's not mandatory, but it'd be nice to have. What is very likely to happen is I just run the frame exactly as it is and make minor adjustments. What will definitely happen is these props, which are right there, are going to be replaced. Those are for the low or summer position. They'll work for now, but I definitely will be upgrading those at a later time. The installation of the support blocks on the outside and all the painting has been completed. There's one of the support blocks. There's the other one. Those are there because when I designed the frame, I wanted the solar panels to overhang the sides to keep the weather off the recycled scrap lumber and the fasteners. The downside of this is that there has to be these blocks, but it's necessary for the design, and I'm just going to leave them on there. They'll do their job. I went ahead and used the last two bars that I had, the steel bars, to strengthen the solar panel frame in the winter position. I will be getting better hardware later, hopefully, but they are good enough, and this solar panel frame is worthy of the additional effort, so I went ahead and put them on there. And I'm pretty satisfied with the rigidity. I may add more diagonal bracing later, but it's good enough for now. It's very stable. There's one more task I have to do before I put this frame outside. I need a very robust and simple solution to hold the solar panels at the bottom to keep them from slipping. I could omit this detail, but I don't like leaving things to chance. I got a whole box of these structural ties. This is what they look like. They're 1 foot long. They're galvanized steel. And they were not intended for this type of work, but they work really well at the bottom of my frame to hold the solar panels and give them a base to rest against. I could leave that detail out, but I'm not willing to do it. There's a closer look at one of the ties after it's installed. It creates a steel lip at the bottom of the frame, And I tried pushing on it and it's quite strong, so I don't think it'll be a problem. In some cases, the full weight of the solar panel could come to rest on these pieces of metal, so they need to be strong and robust. Most of the time it's not really an issue, but I don't want the solar panels to start shifting downward over time. I plan to use a novel and unusual way to attach these solar panels to the frame. I've never used it before. It was suggested by a friend. But in order to use that method, I need something very robust at the bottom of the frame so I can ensure the panels never slip downward. I have some tar paper left over from a building project I did years and years ago. I'm creating gaskets or separators. There's going to be 2 layers of tar paper underneath these door hinges. The reason I'm doing this is the base of the solar panel frame is made out of pressure treated 2x6 wood, and the corrosive chemicals inside that wood will just eat metal to pieces. These hinges are already pretty old and they are rusting, and I have no guarantee how long they'll last, so in order to ensure they last as long as possible, I'm putting 2 layers of this tar paper in between these hinges and the 2x6 base. It is now time to disassemble the solar panel frame and take it outside. At that time, I will install the tar paper gaskets underneath the hinges. I'm not going to show the teardown and reassembly process because I'm a bit short-staffed and I'm under a time deadline here. I've got to hurry and get this thing done. I will cut back in when the base and the frame are outside and take it from there. One more clip. Here's the upper frame and the base disassembled. It's ready to go outside. First I'm going to take the bottom part, which is this part right here, outside, and I'm going to set and level that on deck blocks. That's going to take a while. I don't know how long it'll take. I may have to dig in the ground some to level it. Once that's done, I will take the main part of the frame that goes on top outside and put that on top of it. But I'm not going to do that until I'm sure this base is level and square and everything it needs to be. And there's the frame, the bottom of the frame, sitting on the ground. Unfortunately, it's out of level, so I'm going to have to excavate to try to get it into level. It doesn't need to be perfect, but it's way off. Okay, there's the frame. It's been set up. It was a very long and difficult process. I'm going to keep it in the summer position, which it's in now, and raise it up later. Front to back it was out of level, so I added some sand and earth underneath the paver stones and raised it up about 1 inch to 1.5 inches. And it's almost level. It's good enough. Now I'm going to go ahead and lay some solar panels on there and test it out. Okay, there's the end result. I'm really tired. I need a break. Looks amazing.